Okay, so far we have seen solving a quadratic using factoring. Now, most of us, really all of us, know how to solve using the quadratic formula, and we'll look at that in class next time. But we have not yet visited the lovely land of completing the square, and that's what we're going to look at today. Okay, let's go back though. For example number 11, notice there's only one x term. I wouldn't want to factor this. The only time we factor is if there is an x squared and an x, the quadratic and the linear term. Okay, and usually if there's a constant, that's helpful. If we're just solving for one variable, well, we want to isolate it. So for this particular equation, I would isolate the quadratic term. Again, there isn't a linear term, so I'm just going to solve for x squared. I subtract 5 to both sides, and then dividing by 3, I get x squared is equal to 5. I'm solving for x, not x squared. So I'm going to take the square root of both sides, which is the inverse operation of the square, and x is going to give me plus and minus the square root of 5. Very important two things. Do not approximate. Leave it as the square root of 5. Simplify if possible. This one, unfortunately, is not. And then take the plus and minus, because there are two options. We don't know. We're solving for the unknown. And think about if, and I showed you guys this in class the other day, but if I have x squared is equal to 9, let's say. Okay, well, we've got two options, 3 squared and negative 3 squared. We don't know which one it is, so we need to not simplify, we need to assume both. Okay, so if you're taking the square root in a solving problem, always account for the plus and minus. Okay, example 12, it says find the solution using square roots. I'm going to cross this out. I'm just going to say find the solution. Well, I know that it can't be solved if it's not equal to 0. So in subtracting 9 from both sides, we get x squared plus 12x plus 27 is equal to 0. And right away, I can see that we can factor, because 9 times 3 is 27, and 9 plus 3 is 12. So let's factor this out to be x plus 9 times x plus 3 equal to 0. That zero product property allows us to set each of these equal to 0. We talked about that in class the other day. If there are two terms being multiplied and they equal 0, one of them has to be 0. So x is negative 9 and x is negative 3, and we're going to write our solution set as 1. So two different ways that we already know how to solve a quadratic. One, if there's only one x term, the quadratic term, we isolate it and solve. Second, we can factor. The one we're going to look at today is called completing the square. So let's ease into it, shall we? What is this whole completing the square shenanigans? Well, in completing the square, we need to create a perfect square trinomial. An example of a perfect square trinomial would be maybe x plus 2 times x plus 2. A perfect square trinomial is one that can be factored into perfect squares. In other words, the same binomial multiplied to itself. It's squared. When you multiply it out, we can see, and 2 probably isn't the best example, but we'll use it for right now anyway. You can see that the 2 will multiply to the outside and add to the inside. They multiply to 4 and add to 4. Okay, what about this one? Let's do one that isn't so much. Okay, what about x minus 5 squared? Okay, well, that leaves us with x minus 5 times x minus 5. If we multiply it out, we get x squared plus, oops, just kidding, psych, x squared minus 10x plus 25. Again, the two numbers will multiply to 25, which is a perfect square, and they add to the middle term. Okay, so knowing that about our perfect square trinomials, if we were asked what or how to, we'll say, create a perfect square trinomial, and we're given the first two terms, how in the world are we going to find C? Well, we know that the two numbers have to add up to that middle term, and they multiply to c. So looking at the two examples I gave you, how does 4 relate to 2? And how does 10, negative 10, relate to negative 5? Think for a second, and we should maybe come up with, it is half. The negative 5 is half of negative 10. The 2 is half of 4. And then, how do I get 4? How do I get 25? We square it. So in order to find our c term, we're going to take half of the middle term and square it. For this particular example, 18 divided by 2 is 9 squared, so c is 81. And notice that's because our x squared has a coefficient of 1. That is very important to note. X squared has a coefficient of 1. Why does that matter? Because this process, creating the perfect square trinomial will not work. Completing the square will not work if your a coefficient isn't a positive 1. Write that down. It has to be a positive 1. And I'll say it a bunch more times, don't worry. All right, looking at b, yes, our a coefficient is a positive 1. So in order to find c, I'm going to take half of my middle term and square it. Alas, 9 is not divisible by 2 evenly, so I'm just going to leave it in fraction form, and I'll get 81/4 as my c value. When completing the square, you need to always leave it in fraction form. Ooh, you should write that down too. Always leave it in fraction form. Now, it's not equal to 1, my a coefficient. It's a 2. So how do we get it to be a 1? That's right. We're going to divide everything by 2. Am I allowed to do that? Yeah, it's not going away. You could, since it's not an equation, you could factor it out. We could do that also. And that actually makes more sense mathematically. So we've got 2, and then r squared minus 9r plus c over 2. Now, since this inside part has a leading coefficient of 1, we can complete the square to create a perfect square trinomial. Except we're solving for c over 2, so keep that in mind. All right, we take negative 9/2 squared. Again, 9 isn't evenly divisible, so c over 2 is equal to 81/4. But that's not what we were asked to find. We were asked to find, remember we talked about in class, our end game. What's our end game? We were asked to find c. So if I substitute in 81/4 into that expression, right, how would I get back to c? Yes, we would just distribute the 2. Or if we go back here, we could multiply both sides by 2, which is ultimately the distribution, and we would find that c is 81/2. We are creating our perfect square trinomials. It's pretty cool, mathematically, I think. All right, so we are going to use the completing the square process. Ladies and gentlemen, as we go through this, I will write little reminders, but you should also use your notes accordingly. So if there is something I say that I don't write down, but you want to write it down, gosh darn it, write it down. Here we go. All right, it says exact, find the exact solution. Root 0. They are all the same name. So I'm not going to approximate. No, we're not approximating. We're finding the exact. All right, first thing I need to do is move the c value to the other side. We're solving. I'm going to move the c value. So I get x squared plus 2x is equal to 16. This, I know, it's not equal to 0, Patterson, but I'm not trying to factor. So it's okay. I'm using completing the square. I then, step 2, so step 1, move the c value. Step 2, make a perfect square trinomial. Now, if I add a value to the left side of my equation, I also have to add it to the right, because I'm making a perfect square trinomial doesn't mean the rules of mathematics go out the window. In order to keep this equation equal, whatever you add to one side, you have to add to the other side. All right, so in order to create that perfect square trinomial, Hello, thought bubble yet again. I take half of my middle term, which is 1. I square it. So we're adding 1 to both sides. Okay, step 3, factor and simplify. Well, remember when we talked about our perfect square trinomials, they're beautiful because they factor to the same binomial squared. How do we know what that binomial is? It is half my middle term. Half my middle term. We already saw that. We know that, right? So in order to complete step 3, I'm going to take half my middle term as the factor, and I'm going to square the quantity. How do we know? Well, multiply it out. X squared plus 2x plus 1. And it equals 17. Okay, so step 1, move c to the other side if needed. Step 2, create a perfect square trinomial. Step 3, factor and simplify. Step 4, solve. Now, in order for us to solve, I'm going to have to somehow get that x out of the square. So we're going to take the square root of both sides. We get x plus 1 is equal to plus and minus. Remember, we're solving for a squared term, so we could have the plus and the minus of that value. And then we subtract 1, so x is equal to -1 plus and minus the square root of 17. It said exact. I cannot simplify the square root of 17 any further, so I am done. Not too bad. I actually really like the process, but I know you're a math teacher. You'll like it too, don't worry. Okay. Look at B. What do we notice? We definitely noticed something we haven't seen before. So this is a little bit different. I'm going to add a step 0.5, and that's if your A value is something other than a positive one and you're solving, ladies and gentlemen, this is huge. This is only when you're solving through completing the square. Solving, and you'll see in the next example why I've said it 17 times. Okay, we're going to divide every term by that leading coefficient. Because we are solving, I'm going to write this separately, because we have a 0 on the other side, we have the freedom to divide every piece of this equation by that leading term. And the reason we're dividing is because we need our leading coefficient to be a positive 1. Otherwise, we cannot complete the square. Okay, so if we're solving through completing the square, we can divide through by that leading coefficient if it is not a positive 1. And then we begin with the steps we saw previously. So I need to move the c value to the other side because my equation is in standard form. I need to then create a perfect square trinomial. So I have x squared minus 7/2 x plus some number is equal to -6 plus some number. I don't know what that number is quite yet, but I know that if I add it to one side of an equation, I have to add it to the other. Okay, it's a fraction. Don't be afraid, fractions are your friends. So if I have a -7/2 and I divide it by 2, because ultimately that's what we're doing, right? 2 divided by 2 over here, -7/2 divided by 2. That means that I'm going to have -7/2, I'm going to change my thought bubble, times 1/2. So if you have a fraction as your middle term, what you are doing ultimately is taking the denominator and multiplying it by 2. Why? Because we're dividing by 2, which means we multiply by the reciprocal. Okay, and then I need to square it. So -7/4 squared gives us 49/16. Ooh, that's pretty. So half the middle term squared is 49/16. All right, nicely done. Hopefully we survived that one. So for the third step, we factor and simplify. Now it was easier on the previous example of A because we know that half of our middle term is 1, right? But we also find it here. So if you're like, oh shoot, man, it's a fraction, half my middle term, guess what? We already found it. So I'm going to write quantity x minus 7/4 squared, because again, a perfect square trinomial factors to half the middle term in the binomial. We saw it up here, and it's that binomial squared, which is why we love completing the square, is equal to, oh man, okay, we need common denominators. So that denominator is going to be 16. So 16 times a negative 6 gives us, well, multiply. 6 times 6 is 36. 6 times 1 is 6 plus 3 is 96. Oh, we made it. Plus 49. Nicely done, you guys. All right, did I have 4 steps? Did I miss a step? Oh no, we're still simplifying. Whew! Miss Patterson's losing her marbles, everyone. I know some of you already knew that. That's okay. All right, so now we're still simplifying. So we get the quantity of x minus 7/4 quantity squared is equal to negative 96 plus 49. Oh, and I forgot the 16. Sorry, guys. That gives us a negative 47 over 16. All right, now we're on to step 4, which is just solve. So similar to, yes, you might be noticing a pattern. We need to take the square root, okay? So we get x minus 7/4 is equal to, don't forget the plus and minus, and I'm actually going to take the square root of the denominator. So since it's a perfect square, you're allowed to. We have 4. All right, and then x is equal to, I'm going to add 7/4 to both sides, plus and minus the square root of negative 47 over 4. Sorry. Now you could add the numerator if you wanted, or just leave it like this. I say add the numerator because our denominators are the same. And I hope that at this point, some of you are like, whoa, 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 Patterson, this is all wrong. Yes, this is all wrong. Ladies and gentlemen, you cannot take the square root of a negative. It is not possible. I am so sorry. So even though we had this beautiful process, right? We divided everything by 2 because we were solving through completing the square, and we needed a leading coefficient of positive 1. And then we found, oh yes, we completed the square with a fraction, and we multiplied the denominator by 2 because we had to divide by 2. Oh my gosh, it was so beautiful, right? And then we get to no solution, and some of you are angry at me. I didn't make the problem, but I did choose it because I think it is a really nice example for us. There's no solution. What does this mean? When we're solving, we find the roots, we find the zeros. This means, and a is 2, this means that our quadratic, our parabola, doesn't cross the x-axis. So the vertex is above the x-axis because it opens up, and it opens up never intersecting with the x-axis. The solutions do not exist. Mind blown. So good. So much in that one problem. Let that sink in for a minute. All right. There is one more thing that the completing the square process does for us, and that is allowing us to write it in vertex form. And it's a lot faster. Some of you I saw in the discussion were asking about, well, can I write it in vertex form? You can. We can always find negative b over 2a as the axis of symmetry, substitute it back in to find k value of the vertex, and then write the equation. Or you can use completing the square. So I'm going to do our steps in a different color because they do vary a little bit. I'm going to do these in this fantastic lime green. Okay, when we're writing an equation in vertex form and we're choosing to do so through completing the square, step number 1 is to separate the c value and create a perfect square trinomial. Okay, so y is equal to x squared plus 10x, and I'm going to create a perfect square trinomial. I'm going to separate out the 27, but here's the thing. If I add a number to an equation, I'm totally changing the equation. So my options are, I could add that number out here so that it balances, because now I'm good, right? Mathematically, I'm not breaking any rules, but I'd have to remember to add it back over at the end. I don't want to do that. What I want to do is if I add it to one side, right, to move it over, I would subtract. So I'm just going to subtract it from the get-go. Again, why? Because if I add a number here, so that it's balanced, right? Assume that's not there. I would eventually have to subtract it over to get y by itself. So instead of doing that at the end, I'm going to set up my equation so that it's done for me at the very beginning. Okay, step 2 is to create that perfect square trinomial. I'm going to take half of my middle term, which is 5, and then I'm going to square it. So I get 25. That means I am adding 25 and I am subtracting 25. Step 3 is to factor and simplify. So y is equal to half the middle term again we found up here, x plus 5 quantity squared. Simplify 27 minus 25 and we get plus 2. And ladies and gentlemen, I am in vertex form. Yeah, it's really that easy. It's pretty fantastic. There's A, H, and K. Okay, now this is just an extra tool, an extra resource for you. And that's why I think it's important to see. Sometimes it's easier to do that than find our negative b over 2a. Now, ladies and gentlemen, what if I ask you to do this one? Wah, wah, wah. Yeah, oops. There's a 2 in my a value, and I cannot use completing the square unless I have a positive 1. Okay, here's our 0.5 step. Since I do not have a 0 on the other side of the equal sign, I actually have a y. This is different than if we were to solve. I'm going to factor, this is step 0.5, I'm going to factor the 2 out of the first 2 terms. I'm only going to factor the 2 out of the first 2 terms. I'm not using the 10 to create my perfect square trinomial. I'm only going to factor it out of the first 2 terms. Why? Because I'm not using the 10 to create the perfect square trinomial. Okay, that's key. So now for step 1, we've already separated C. We're going to create, well, I guess step 1 would be putting in those dashes, right? Those lines. Okay, so for step 1, we're now going to create our perfect square trinomial. We're putting in the lines. Remember, if I add it, I also have to subtract it. And think about it over here. If I add 25 and subtract 25, what am I adding? Yeah, I'm adding 0. So therefore, I don't change the value of my equation. That's how we get away with it. Okay, step 2 is to create the perfect square trinomial. I'm going to take 7 halves and divide it by 2, which means we're taking 7 halves and multiplying it by 1/2, so we get 7/4. I know this looks familiar. Then we get 7/4 squared, which leads us to a 49/16 fraction that we are adding and subtracting to our equation. But be careful, because I'm not adding 49/16. Notice there's a 2 on the outside. So I'm adding 2 times 49/16. This 2 is eventually going to get distributed in. That's mathematically what it represents when there's something outside of the parentheses. So when you have to factor out a 2 in order to create a perfect square trinomial, you need to account for it on the number that you are subtracting. Okay, you might want to write that down, highlight it, star it, square it, some way for you to remember that if I factor out my a value from the first 2 terms, I must multiply it to whatever number I add and subtract. And then our final step is to factor and simplify. So y is equal to 2 times, that's half my middle term, so we get x plus 7/4 squared plus 10 minus, this is 2 times 1, so it's really just 49/8. Keep going because we need to add the fraction, so 2 times x plus 7/4 squared plus 80/8 minus 49/8. And our final step, we're almost there. Oh my gosh, we did it. 2 times x plus 7/4 squared, and then 80 minus 49 gives us a 31/8. That would be so fun to graph, said no one ever, because it's a little bit harder for us to approximate. Could we do it? Absolutely. Nice job, everyone.